Hi students, in this class we are going to study what is meant by skin effect in the transmission lines. If you consider the direct current flowing through a conductor, the current is distributed uniformly throughout the cross section of the conductor. But this is not the case with the alternating current. When AC flows through a conductor, the current has a tendency to flow through the outer region or the skin region of the conductor, and this is called a skin effect. And now we will see why the skin effect occurs when alternating current is flowing through a conductor. We consider this particular current carrying conductor. Certain magnetic flux lines are produced by this current carrying conductor. We have both external flux lines and internal flux lines. Suppose we have 5 number of flux lines in this particular conductor. 2 are external flux lines and 3 are internal flux lines. Now consider the current flowing through this particular annular filament. Actually, these 2 flux lines are surrounded by the current flowing through this annular filament, or 2 number of flux lines are linking with the current through this annular filament. As you know, the inductance is equal to the flux linkage per current. In this case, the flux linkage is these 2 flux lines. So we will get an inductance according to the flux lines and the current. As you know, inductive reactance is equal to L omega. So proportional to the inductance, there will be inductive reactance in this area. Now we consider this particular annular filament. What is the flux linkage now? Now these 3 flux lines are linking with the current flowing through this annular filament. So now the psi is increased. When psi increases, the inductance increases. So the inductive reactance will also increase. So in this annular region, we get more inductive reactance compared to the previous one. Now we consider this annular filament. Now we have 1, 2, 3, 4 number of flux lines surrounded by the current through this area, or the flux linkage is increased. When the flux linkage increases, inductance increases. So inductive reactance increases. Now we can consider this central part. All the flux lines are surrounded by the current through this area, or we have more number of flux linkage with this particular current. So the inductive reactance will be maximum at this area. The closer you go to the center, the more the inductive reactance. So the current has a tendency to flow through the outer regions, because in the outer areas the inductive reactance will be minimum. So this is how the current flows through the conductor. The maximum amount of currents will flow through the outer region or the skin region of the conductor. So we call this effect as skin effect. Now we will see the factors affecting the skin effect. The first one is the shape of the conductor. Instead of using one single solid conductor, we can use composite conductors. For example, we can use ACSR conductor. ACSR conductor means aluminum conductor, steel reinforced. So at the center we have steel conductors for the reinforcement, and this space would otherwise be wasted because no currents would flow through the center part, or minimum currents would flow through the center part. Now by using the steel wires we can increase the mechanical strength of the conductor, or you can use a hollow conductor because through this area minimum currents will be flowing, so you can make it hollow. The other factors affecting the skin effect are frequency, diameter, and the material with which the conductor is made. When the frequency increases, the inductive reactance, which is equal to L into 2 pi f, that will increase. The skin effect will be more. When the diameter increases, as you know, the more amount of central part will be wasted. So higher the diameter, the more the skin effect. If you use a material with a higher permeability, again the inductance is more, so the inductive reactance will be more, the skin effect will be more.